Hello students, today we are going to talk about geography section which is important for our NDA as well as serious examinations. So in this portion we'll talk about physical geography and human geography. And in both these section we have to talk differently, we have to study differently about Indian physical geography and world physical geography. Fine. Likewise, we have to differently study about Indian human geography and world human geography. So I'll tell you what all the topics which are important in these sections. First of all, nowadays we see that there is a shift in the pattern of UPSC examinations where the examiner is more interested in the world physical geography section. Fine. So this part remains quite important to us. Now, this change in pattern of our examination, where earlier it used to be concentrated or it used to be focused on Indian physical geography and then Indian human geography and then some static portion from the Indian political map as well as physical map. Now the examiner has started asking question more about atmosphere, structure of atmosphere. And one thing I'll tell you that in this world physical geography there are only few topics which are very important, from where you'll find n number of questions, and all you have to do, you have to study 11th class NCRT textbook. Fine. Okay, so in this world physical geography section we have to first focus on the climate. So this climate unit is quite important, because in this climate unit you will not only study about what all the climatic classification being done by Copains, but beyond that we have to understand what are the components of climate, for example temperature, atmosphere, humidity. So here we'll study in this climate portion, we'll study about the atmosphere, which is important. In this atmosphere section we have to focus on its structure, its composition, and its role. Fine. And some terminologies related to it. Fine. So when we talk about now, what I'll do is when I tell you about the important topics, I will shortly uh, give you some details, some explanation as well as some facts related to that, where you'll get a better understanding about how we have to focus on these particular topics and what all facts we have to remember and what all concepts we have to understand. Fine. So for say, if we are talking about the structure of atmosphere, so for the structure of atmosphere all we have to understand that, okay, this is this is our atmosphere. Fine. And this is the earth's surface. So the first layer of the atmosphere is the troposphere. Then we have stratosphere. Then there is mesosphere. And then comes the thermosphere, or this thermosphere is also known as ionosphere. Fine. And then there is exosphere, about which there is very little to know, very less amount of facts are available, because scientists are even not able to explore and understand this exosphere completely. Fine. Okay, now see, each and every layer of this atmosphere holds some significance, and what all role does it plays, it is quite important. For example, troposphere. So this troposphere is the life giving layer of atmosphere to the human, to all the living organisms in the planet. Fine. Now this is very near to earth, it's almost about 13-14 kilometer from the equator, and this troposphere contains all the weather like conditions. When I say weather like conditions, it simply means that cloud formation happens over here. Fine. Precipitation, condensation, every element of every basics of the weather condition is formed in this layer. Then we have to talk about then we are talking about stratosphere. Now in this stratosphere, since our childhood we have been told that uv rays, which are harmful to the life, to our to our skin, it may cause cancer, skin cancer, and uv rays are harmful rays and so on. So this stratosphere plays a very significant role in absorbing those uv rays. Why? Because stratosphere contains ozone layer. Stratosphere has got ozone layer, and uh, ozone's chemical formula is O3. Fine. Now this ozone layer is there, but other than this, if we see that all the flights, fine, all the flights take place in this portion stratosphere. Why so? Because to fly in the sky, the pilot needs a clear vision. And as we know that troposphere contains the cloud form, has got the clouds and everything. So stratosphere is cloudless. It has got no weather like conditions. So it gives a clear path to travel, to fly over. Fine. Okay. Then we have mesosphere. So this is the portion from where the the temperature of the atmosphere starts declining, and it declines at a very you can say sharp rate. Fine. And beyond this mesosphere there is thermosphere and ionosphere. Both the names holds its characteristics. For example, why it is called thermosphere? Because in this thermosphere, now as we seen that in mesosphere there is almost minus degree Celsius temperatures is going on. So if when we enter to the thermosphere, we'll experience that now the temperature starts increasing, rising. So that is why it is called thermosphere. And why ionosphere? Because as we know, all the radio waves, all the satellites, were, because satellite sends the radio waves and all those signals, those all works over here, because this layer contains ions. Fine. And these ions only help our satellites to to receive and to send this all the signals and all the messages. So this is quite important. And then comes the exosphere, as I told, as I mentioned earlier, that there is very little to know about this, because scientists remained unable till now to know completely about this exosphere. Fine. Okay. Now we talked about the structure. Let's see that the composition. Let's talk about the composition of the atmosphere. Okay. Before moving to the portion of composition of atmosphere, let's first understand what is atmosphere. So atmosphere is basically, since during our childhood we have some some definitions given to us, that atmosphere is the layer of air which surrounds earth like a blanket. Fine. It is completely true. But what we now, as defense aspirant, what we should know about this, that this atmosphere is layer of air, and air is not made of some made of a single gas. It is a mixture of gases. Okay. So atmosphere is has got air, and that air has got different gases, and these gases are in particular or defined proportion, and that your examiner is keen to know about your knowledge there. So you see, in the composition part, you must know about the, for see, I'm making a pie chart. So for almost 70%, fine, uh, for almost 70% of our or more than that even. Okay, so we'll see this much. This is even more than that. So more than 70% of the gas which is present, it's almost 78% nitrogen gas which is present in atmosphere. Then comes the oxygen which is present in 21%. This is oxygen, fine. And in this 1% we have got argon, carbon dioxide, fine, and there are other noble gases, for example helium, xenon, radium, fine. So all these gases are further, so all these other gases are further added to the or a part of this atmosphere's composition, fine. Okay, now let's move to understand. Let's see that other than these gases, what else we have? We have water vapor and dust particles, fine. So it is quite important to understand that beyond the gases, we, or beside gases, sorry, we have water vapors and dust particles present in our atmosphere composition, fine. Okay, then we'll I was talking about the role of atmosphere and the terms related to it. So role of atmosphere is basically to provide to provide the essential living conditions which supports life, which maintains life. And what all terms related to it are basically, for example, you must know what is atmospheric pressure, how does what devices are used to measure atmospheric pressure. Atmospheric pressure has got vertical atmospheric pressure, horizontal atmospheric pressure. So we are talking about the distribution of atmospheric pressure. Now to you must have heard about isobars. So isobars basically are the lines joining joining the places in the map which has got which have got same atmospheric pressures, fine. So these are few terminologies which are related to this atmosphere portion. And then in the climate section, again, as we are talking about the climate section, which is important, very important rather. So now we, as we talked about the atmosphere, its structure and everything, then we have to learn about water in atmosphere. And when I say water in atmosphere, it basically means that uh, humidity. What is humidity? Humidity is basically, okay, let's come to the terms related to it, and let's see. So first we are talking about humidity. So humidity is the water holding, yeah, we can say this moisture, fine. It's better to use moisture holding capacity of air or atmosphere. Fine. And humidity is further subdivided into absolute humidity and relative humidity. Fine. So absolute basically means that what uh, actual amount of water it is retaining, atmosphere is retaining, or air is holding. And this relative means that now there is a comparison. Now its potential is this, and how much it is holding for now. So this is relative humidity. Now water in atmosphere also talks about condensation. Fine. So we see different forms of condensation in our atmosphere. So when I say different forms of condensation in our atmosphere, it simply comes with clouds are very common. Clouds, precipitation, clouds, precipitation. Then we have fog and mist, dew, frost. Fine. You see, each of these form of condensation has got its own characteristics and has got its own you can say definition. Fine. Now the examiner, what is you can find in your exam that there at one side the examiner has got these names, for example fog, mist, dew, frost, and on the other side the examiner has given you their definitions or their characteristics. Fine. And now you have been given further options to correctly mark or to choose the option which you feel correctly marked as pairs. Fine. Now you see, clouds are basically uh, the water vapors which get condensed at certain altitude. Fine. So clouds cannot be formed just near to your foot. Fine. Or near to your leg. No. The formation of clouds happens or take place at a certain altitude. Fine. It can be for example uh, 8,000 meter. Fine. 12,000 meter. These are the high altitude clouds. So low altitude clouds also lies, for example, in a 3,000 meter or 2,500 meter. So it has got certain altitude to be formed. This is condensation in the form of clouds. Then comes precipitation. So we know that precipitation, now precipitation has got further division. For example, one is rainfall, which is very common. Everyone knows. Rather, we actually feel that rainfall is precipitation. Precipitation is rainfall, but it is not true. Fine. Rainfall is a part of precipitation. Now, other than rainfall, there is snowfall. You'll see hailstone. Fine. And so on. You'll have certain sleet. So these all the release of moisture from the clouds at different temperatures or at different places where the temperature is very different. For say in non-freezing uh, in non-freezing geographical area, there'll be simply rainfall. But when the temperature is 0 degree, when it's winters, so you'll see that there are snowfall and hailstorm take place when there is sudden change in the there is stark difference in the upper and lower level of the atmosphere in its temperature term. Fine. Okay. Then fog and mist. So there is a very subtle difference and very small difference between fog and mist. They both remain same in order of their formation and everything, but there's just a small difference, and which we'll talk later. First, just see what is fog and what is mist. So fog and mist is basically like now the water holding capacity of atmosphere has reached its potential. Fine. Now the air is saturated. When air is saturated, now it will release small or tiny droplets in the atmosphere. These tiny droplets are so small in their size that it may appear like it is white thin clouds coming to you, or there's a smoke around you, which is actually nothing but tiny droplets. If you have studied in your science section about the Tyndall effect, from that there you can see that even if you scatter light on it, then you'll find that actually it is raining. Actually it is small droplets of water which the atmosphere itself is releasing. There are no such clouds over there. Fine. And these small uh, droplets, when they get clustered, they form cloud like cloud like structure around you. Fine. And the difference between fog and mist is basically, first, their location. Fog is generally formed in low lying areas or low latitude areas, whereas mist is formed in the hilly region or mountain region. Fine. And mist is denser than fog. So mist has got more moisture. Okay, then comes dew and frost. So dew point, as we know, dew point is basically when you reach first of all, let's understand what is dew. So during winter, when we come out of our home in the morning, we see that there are grasses. There are grasses and with tiny droplets, which are quite, you know, cold. And we see that cars standing parked outside, their windows are, condensed with those droplets. So what is it exactly? So dew is basically, again, your your temperature in your surrounding is very low, and at that time what happens basically, that is called dew point. Fine. So at that time what happens basically, that cold air, fine, that cold air, when it touches uh, comparatively cooler solid surface, then it actually gets condensed. As we know that when we take out our water bottle from outside out from the fridge, and we keep it for a while on table, we'll see that there are tiny droplets around the bottle. Fine. What, how it forms these droplets, where are it coming from? It's basically the air which touches that cold water bottle, and it gets condensed. Fine. So likewise, there's a temperature difference between the air and the solid surface, and when the air touches that cooler solid surface, it basically it basically condenses it condenses into tiny droplets, which is called dew. Fine. So there is a dew point, 0 degrees Celsius. And then comes the frost. So frost are basically those flakes of ice and or snow, we can say. And these are formed by when when there is freezing point in the atmosphere. So dew and frost is more or less same, but their structure, dew is in a liquid form, and frost is in, we can say, like, it is in a solid form. It's snowflakes sort of. It has got its structure and texture. Fine. Okay, so now we have talked about the condensation, we talked about the rainfall and everything. Now further, there is a division in rainfall. Fine. So the first type of rainfall, we can orographic orographic rainfall or orogenic rainfall. Then there is cyclonic rainfall, and orographic rainfall, cyclonic rainfall, and then there is a torrential. Yes, fine. Let's first discuss about these two. So in the orographic rainfall, oro means oro is related to mountain. Fine. So oro means mountains, and when so let's make a when the clouds are formed, and basically what happens that now there are clouds formed, these clouds will touch or will get hit by this windward side of the slope, so it will basically shed its moisture because these are quite heavy. Now they cannot fly higher altitude, so these clouds have to remain just near to the windward side of the hilly region or mountains, so they releases their moisture. And what happens after releasing the moisture, these clouds get lighter and flies above, and in this part there is no rainfall. This is leeward side of the hill, and this is windward side. Fine. And so this windward side is also known as rain fed zone, and this is also known as rain shadow zone. Fine. So this was about your orographic rainfall. So then comes cyclonic, and the third one is convectional rainfall. Okay. So for cyclonic rainfall, now let's move to another page. We are talking about rainfall. Now we are talking about cyclonic. So we know that cyclonic rainfall basically are the rainfall uh, which which occurs because of cyclones. So cyclones are those gusty winds with thunderstorms, and with these are torrential uh, rain. It causes torrential rainfalls. Now these gusty winds, they actually, if you see the tropical cyclones or the cyclones, they basically originates from the water body, large water body, that is it can be a it can be an ocean, it can be a sea. So from there, when it originates, it receives a lot of moisture, and when it receives a lots of moisture, so it is able to shed those moisture to the nearby coastal region. But as the cyclone moves towards the interior part of the land, it actually disseminates its moisture, and due to which it is weakened, and now as it completely cut off its contact from the water body, and there is no source to further refuel the cyclonic clouds, so this rainfall or this cyclones gets completely end in the interior part of the land. Fine. And after the cyclonic rainfall, we have convectional rainfall. Fine. So what is convection actually? uh, we must have, sorry, we must have learned types of process of heat transfer in science. And we know that there are there is conduction, there is convection, and then induction and radiation, so on. So convection basically means that now this is a land, and this land gets heated up due to intense heating. What will happen? This land is, hotter than the surrounding or the above upper part of this atmosphere. So what will happen? This heat will get transferred. To transfer these heat, the particles of the hot air will rush toward the upper colder air, and then as they reach over there, the colder air sinks downside. Fine. Now this is convectional way of heat transfer. But if we see that how does these convection currents causes rainfall, so as the hot air moves upwards, there is a formation of clouds ups at the upper layer of the atmosphere. Why? Because the upper layer of the atmosphere is cooler. Fine. So as soon as it reaches there, it gets condensed, and when it gets condensed, simply in this part there is a vacuum, there is a low pressure created, and this low pressure attracts those air, as well as this low pressure attracts rainfall. And this such type of convectional rainfall is short lived, it's temporary, it is unevenly distributed and uncertain. Fine. Okay, fine. So we have talked about atmosphere in the climate, and in that atmosphere we further talked about the water in atmosphere, the condensation part, and then humidity and everything, and then we talked about types of rainfall. Now let's see climatic classification of world and Indian regions. Fine. So for the classification of climate, there's one scientist, Copain. So the Copain's classification is famous for classifying different climatic zone on the earth or in the world, and then also it's been used. It is used in India to further classify the Indian climatic conditions. Fine. And then this in this Copain's classification, Copain's has used certain alphabetical capital alphabets in this. Fine. So he has used A, B, C, D, and E. Fine. So Copain's has used these five alphabets. Later on, H was added, and I'll tell you that what does this H stands for. But let's see, what is this A. So A, now first of all we have to understand that for the classification part, Copain used temperature and precipitation as the basis. Fine. And only this B, alphabet B, is related to the precipitation, because B talks about uh, the rainfall of that particular region. And when you'll see that this B is further added with W and S in the context of India as well as in the world. So W is arid and S is semi-arid. So arid and semi-arid is simply related to the amount of rainfall that particular region receives. Fine. Okay, fine. And then the rest four are related to temperature. So if we say this A is related to the tropical region. Fine. it can tropical region, and also we can somewhere we can consider equatorial region. Okay, so it says that even in the coldest month of these region, there there will be temperature of at least 18 to 22 degree. Fine. And or we can say then there is annual temperature of 18 or 22 degree. Then comes C. This C stands for temperate zone. So again, it talks about the uh, temperature of the coldest month, which is less than uh, which is up to 10 degree. Fine. And then comes this forest, but this is snow forest region. It talks about the snow forest region. So what does it mean, snow forest region? It basically means that it is even colder than the temperate ones. Fine. So it is up to 3 degrees Celsius. And this comes E stands for the tundra like climatic conditions, where the temperature is below 3 degrees Celsius, or even minus 3 degree Celsius. Fine. So now what how it is important for, in the context of India. First of all, India, the climate of India is monsoon type. India is monsoon type. And the code according to Copain being given to India is India's climate is AM. Fine. But there is further classification regarding Indian climatic zones. For example, if you see the westernmost part of India, uh, in the Rajasthan region, the westernmost side of the Rajasthan region, you'll see that it has got the code called BWH. BW. And then the semi-arid area has got, it should be K. Fine. So as I mentioned earlier, that one stands for the arid region, and the other another stands for semi-arid region. Fine. Okay. Then it is actually, let's see, for T. Now there is CWG. So the CWG for Indian context, it stands for the Gangetic Plain. Fine. And E, for example, polar type. This is polar type. This E stands for the Leh Ladakh region, for the Greater Himalayan region, Trans Himalayan region. So this is how given in your exam, the examiner asks you different questions. It can be one word, there can be statement based, but all you have to remember is the code, the major code, and then there is further table given in the NCRT which talks about the further classification. Fine. Okay. This is W, and these small letters even hold some meaning. For example, this M holds monsoon type, and there is a small letter called F, which means no dry season. So we all have to study about all the codes, but the basics are these. And this H stands for highland climatic conditions. Fine. So this is all about the climatic section portion of world physical geography, and rest will cover in our another class. Thank you.